Okay guys, we're going to continue on to section 2.2, complex numbers. Now we've dealt with complex numbers when solving polynomial functions where you get an imaginary solution. That's what a complex number is. But today we're going to deal with operations with complex numbers. As you can see here, our objective: add, subtract, multiply, and divide complex numbers. And we're also going to graph complex numbers on a complex plane. So go ahead and take out paper for notes and write down the objective and the section. Okay, so let's go ahead and get started. The standard form of complex number is of the form a plus bi, where the real number, or the real part, is a, and the imaginary part is bi. So anytime you have a complex number imaginary solution, it should always be written in standard form, a plus bi. So recall that when we were solving polynomial functions, or in this case a quadratic, when you have a negative inside the radical, that is an imaginary solution. So let's go ahead and work this out just as a review. We subtract 11 here to both sides. Divide by 2x squared, just 2x, sorry. Divide by 2. And when you take the square root and you have a negative inside the radical, that comes out as an I. Don't forget to put plus or minus. That negative comes out as an I. I have square root of 24, but as we've been practicing in the last section, we need to simplify the square root of 24. So think of factors of 24, and one of them is a perfect square. 4 and 6. What's the square root of 4? 2, right. So we have plus or minus 2i square root of 6. So you've been dealing with complex numbers in solutions when we solve, but today we're doing operations of regular operations: adding, subtracting, multiplying. When you add complex numbers, you treat them as if you were combining like terms. You add 8 and 5 and you get 13, and you add negative I plus 4i and you get 3i. So it's like you're adding variables. You just treat I as a variable. Now on B, notice it's subtracting. So make sure you distribute that negative first. When you distribute the negative, drop the parentheses, because many times students will leave the parentheses and end up multiplying the problem. But always remember what the original problem is asking you to do. They're asking you to subtract. Again, combine like terms. So 7 minus 3, you get 4. And notice that the negative 6i and the positive 6i, they cancel. So you just have 4. All right, go ahead and try C. I'll give you a couple seconds to get that started. Okay, so after you distribute that negative, we get 10 minus 6 minus 7i. Again, don't forget to drop the parentheses, and then bring down the plus 4i. Combine like terms, and you get 4 minus 3i. Good. All right, so that was adding and subtracting. Let's see multiplication. You treat it exactly the same as if you would if that was just any other variable, x. A, you would just distribute the 4i, and I get negative 24i plus 4I times I would be I squared. Now the thing about imaginary complex numbers though is if you recall I equals the square root of -1. If I were to square both sides, what would I get? What happens on the right side here with the square root and the square? They cancel, right? So when they cancel, you get another fact that I squared equals -1. Well, that's what we're going to use when we multiply. Because remember, all your complex numbers should be of the form a plus bi. Nowhere in the standard form do you have I squared. So we have to substitute I squared for -1. So when we substitute, we get -24I plus 4 times -1. So when we write it as in standard form, we get, let me erase this. When we write it in standard form, we will have -4 minus 24I. Okay, and then part B, again, you treat it just like if it was a regular polynomial. We're going to do the FOIL method. Multiply, first times first, -36. Outer times outer, 63. Inner times inner, 8I. Last times last, -14I squared. Again, you're going to substitute for I squared equals -1. So what happens is every time you have I squared, it just switches that sign because you multiply the -14 times the -1. So it becomes plus 14. So you can just, when you change that sign, you could just get rid of the I squared because I've already multiplied it with -1. Alright, so combine like terms, -36. Remember this is positive 14. We get -22 plus 71. Okay guys, so we've done adding, subtracting, multiplying, and now we're going to do dividing. With dividing complex numbers, you multiply by the conjugate. If you look up top here, complex conjugates, it's kind of like difference of squares where you have the same exact binomials but different signs. And as you can see here, they give you an example where they FOILed it. And what happens is the middle two will cancel out. And that's what we want with complex numbers, is so that the imaginary part cancels and we are just left with a real part in the denominator. So what we're going to do in this problem here is we're going to multiply by the conjugate of the denominator, which will be 1 plus 4i. You do it to the top also. And you FOIL top and bottom. So go ahead and FOIL that. Again, first times first. Okay, and then FOIL the denominator. We get 1. Remember that the middle ends up canceling. And when we get to I squared here, remember to substitute for -1. So the 20 right here, the plus 20I squared and the -16I squared, you're going to substitute for -1 and your sign switch. So go ahead and switch it'll become -20 and plus 16. You can cancel out the I squared. When you combine like terms, you get -13 plus 33I all over 17. Now, because we're talking about complex numbers though, we have to write it as in complex form, in standard form. So the real part would be negative 13 over 17 plus 33 over 17i. You have to write it as in standard form. All right, a couple more things before we're finished here is I want to simplify I to a power. Again, you're going to use the fact that I squared equals negative 1. And what you're going to do here is you're going to find the closest multiple of 2 to 9, which is 8. What we're doing is we're expanding. I need one more I so that when I add those up, 8 plus 1, I get 9. So I'm just expanding it here. So what I do with the I to the 8th power is you're going to rewrite it using I squared as 2 to the 4th power because you multiply those two to get 8. Don't forget you still have that I. And the reason I wanted to do this is so that I can substitute negative 1 for the I squared. What you're doing is you're trying to simplify I to the 9th power as much as you can. Okay, so what's a negative to an even power? Positive, right. You're always going to have a positive when you have a negative to an even power. And then you have 1 times I is I. All right, good. Now, what about B? This is B. Whoops. Well, B is already an even exponent. So you don't have to do what we did in part A because I could already rewrite it as I squared to the 6th power. Again, 2 times 6 is 12. That's why I was able to do that. And the reason I want to do that is so that I can substitute negative 1 for I squared. And we have negative 1 to an even power is positive 1. Notice you got something different from A. You got 1, not I. All right, and then the last thing we want to do, or I want to do here, is show you how you graph complex numbers. It's really easy to graph complex numbers. It's nothing funky. There's no funky graph to it. All it is a point on the plane. What happens is your x-axis, as you know it, becomes the real number, the real part, and the y-axis, as you know it, becomes the imaginary part. When you graph like A, 3 minus 2i, you go 3 to the right and down 2. That's A. It's just a point. That's all it is. It's just a point. B, negative 2 plus 4i, you go negative 2 to the left and up 4. That's B. C, 3i, would just be on the y-axis. So it would be up 3, 3i. And D would be negative 4 to the left and down 3. That's D. Okay, so go ahead and work on these problems, and you have the rest of the period to work on these. This will be due next Friday. Okay, I'll see you tomorrow. We'll talk to you tomorrow. Bye-bye.